Okay, I'm just writing a few things about the test up on the board for you. So if you're watching the recording or whatever, I'm going to leave. This is going to be up here for a little while. And we're going to talk about specifically what's on the test. First of all, notice there will be no live class session on Wednesday. That's because I'm giving you that time to take the test if that's the best time for you. This will be test 2 over chapter 3 and section 4.1. If you want to earn the extra 5 points on this test, you need to have all of your chapter 3 homework, the things that start with HW and the HW for 4.1. You need to have all of those things, all of those HW assignments up to 90 or higher to get the 5 points. And there probably will be a bonus question or two on the test itself. I will make the test available on Wednesday to start. I don't know what time yet, but probably around class time, 10 or 10:30. And then it will be due. So I'm giving you quite a big window here to take this. It will be due Sunday evening at 11:59. And you will have one attempt. There will be some problems where you need to show work. So there'll be one attempt here. There will be some problems on the test where you'll need to show work in my stat lab. Be sure and practice showing work on some of the problems, practice with the typing tool and stuff so that you can show your work as neatly as possible. You shouldn't wait until Sunday to take it just in case there are any issues. What I would plan on is I would use Sunday as a backup day and plan on taking the test by Saturday, on or before Saturday. That way, if something goes wrong, like your internet goes down or something else crashes or some major ordeal happens, you'll have this Sunday. Always leave yourself a day for backup. Never start the test like right when it's due. That's a bad idea. If you do that and something goes wrong, there's not going to be anything I can do for you on that. So don't email me if you start it like 2 hours before it's due, like at 9:59, and it's asking you for a password or it's asking you for this or that, and your Proctorio isn't working. Guys, that's too bad. I'm sorry. You need to practice with the Proctorio quiz to make sure Proctorio is working for you on your device. Okay. And you need to start it before Sunday, so if something goes wrong, we can get it fixed, and then you'll have Sunday to take the test. So we're going to use Sunday as a backup. Try really to take it on or before Saturday. You will have one attempt on the test. And I was going to tell you about how many questions. I haven't actually made the test yet. But I'm going to make it similar to a test 2 that I've given in class before, and that test had about 25 questions on it. So we'll write that down. About 25 questions. Most of those questions come from chapter 3. There will be one question where you have to do the mean variance, where you have to do variance of a discrete random variable. There'll only be one question where you have to do the variance. There might be 2 where you have to do the mean, because on the one where you do the variance, you'll also have to do the mean. So I may have one question where it just asks for the mean of a discrete random variable, and then there might be another question where it asks for the mean and variance and standard deviation of a discrete random variable. Then, so I would count on from section 4.1 about 3 or 4 questions. Kind of work our way backwards, okay? So from 4.1 maybe 3 or 4 questions. And then from chapter 3, the last section of chapter 3, remember, was probability and counting. And that had to do with permutations and combinations and using the counting rule. And there's about, I would say, 4 or 5 questions from that section. That's 3.4. There's 4 or 5 questions from that section. And remember also that not all questions will be equally weighted. So make sure you pay attention to how many points they're worth. So a question that asks you to do the variance of a discrete random variable is going to be worth more points than a question that says, are these two things events independent? All right. So keep in mind that not all questions are weighted equally. So while this is 3 or 4 questions, it's probably going to be worth, I would count on that section alone being worth at least 10 points of the test. And then from 3.4, about 4 or 5 questions, then the rest of the questions, so that right there, that would be, count on 9, at most 10 there. So that means the rest of them, so about 15 questions, will be from sections 3.1 through 3.3. And you saw what some of those questions would be when we went over that learning catalytics quiz just a little bit ago on 3.1 through 3.3. Okay? Any questions before we go on? I thought we would do the review learning catalytics quiz together, go over it. So I'm going to try to sign in on, actually I think I'll sign in on it on my other device so that we can use the board here. So any questions about the test? Is there anything I didn't cover? Remember, you will access the test the way you did test 1 through Blackboard. However, you will open up My Stat Lab and have just that tab open, and then your Blackboard tab, and then you'll go to tests, and I will send you instructions for taking the test. So I will repeat this all in an email. I'll repeat the instructions for taking the test in an email so that you'll know for sure. And you can have on your desk, of course, a calculator, scratch paper, and your formula sheet, and you can write whatever you want on the back of the formula sheet. Okay? I think that's it. Do you guys have a question? Is there anything about the test in particular that I didn't cover? If you've been doing all the homework, and if you paid attention, we went over that last learning catalytics quiz, and you pay attention for this learning catalytics review quiz, I think you'll be in really good shape for this test. Really, the only one that's extremely time consuming and you have to be really careful on is going to be that one variance question, and it's probably going to be worth 3 or 4 points. So you'll want to be careful on that one. But the others, it's mainly just a matter of knowing your definitions and having your formulas in front of you, and like knowing the difference between, well, you'll see in the review quiz today. So we're going to do that together. So I'm going to open that up. If you have a question, type it in the chat. If you have a question about the test, type it in the chat, or you can turn on your microphone and ask. But I'm going to pull up. We're going to do the Learning Catalytics quiz review for test 2. So I want to make sure, if you'd like to take it with me now and get it out of the way, go ahead and go to My Stat Lab. Leave this on so you can hear me talking. And you can go to My Stat Lab and try to find and open up that Learning Catalytics quiz. It should be right there as soon as you sign into the class. And then I'm going to erase this stuff so that we'll have some room here. And I'm going to pull this up, and we will do as much of it together as I have time for. Okay, question 1. Everybody with me? Hopefully you're taking this quiz with me. Question 1 says, which of the following numbers could not be the probability of an event? Okay, this time it says could not. The one in the last quiz said which of these could be. Remember, we talked about what kinds of numbers can be probabilities, that probabilities have to be between 0 and 1. This time, you're looking at the choices and you're trying to find which one of those numbers cannot be a probability. So hopefully you are doing those with me. I am going to try something. So I'm giving you a few minutes to look at that. And we're looking for a number that's not between 0 and 1. Okay, that is between 0 and 1, Cecil. 0.01 is between 0 and 1. That could be the probability of an event. It's a little zero. What?
I think it was negative 2.5 or 2.5.
Right, and why? Why, Diamond? Why is that one? Why can't that be a probability? What's wrong with it?
Because it's negative?
Because it's negative. Right, good job. Let's go to number 2. Number 2 says, in a probability distribution, the sum of the probabilities of all outcomes must equal what? And this was actually on the previous quiz that we went over before the break. Right, Temperance. The sum, that means when you add up all the probabilities, they have to add up to 1. Okay. Number 3. Which word indicates that you should add the probabilities of the event? So we have 2 words, really, just 2 words, even though in this multiple choice I gave 4 options. But there's 2 words, and one of them means you should add the probabilities, and one of them means you should multiply the probabilities. Which word indicates that you should add the probabilities of the events? Or to add, that's right, Temperance. Good. Okay. Now, if any of you don't know these as we're going, make sure that you make note of it. I need to get out of the way. It says I have low quality video. If there's any of these you don't know, be sure to write them down so that you'll get them right on the test. We are on number 4. So or means to add the probabilities. So which word indicates that you should multiply the probabilities? And we just did an example right before the break. That's right, Kayla. And means you should multiply. And you don't really even have to remember that, guys, because if you use your formula sheet, you'll see that when it talks about the probability of A and B, they multiply. And when they do the probability of A or B, they add. So you don't even have to remember that. You have your formula sheet, okay? Number 5. This one says compute 3 factorial times 0 factorial. Can anybody tell me what is meant by 3 factorial? How do you find just that part? What does factorial, that exclamation point, mean to do in math? 3 times 2 times 1, right. So this part is 3 times 2 times 1. Then for 0 factorial, I told you what that should be. Did anybody write that in their notes? I'll give you a hint. It's not 0.
1.
That's 1, right. So we're taking the 3 times 2 times 1 times 1. Okay, so hopefully everybody will get that right. And I see 6. Okay. Okay, good. Let's go to number 6, guys. And I can kind of see as you guys are answering here. Number 6, it looks like everybody got that one right, by the way. So the answer was 6. Number 6. It says a blank is used to determine the number of ways R things can be chosen from N things if order does not matter. Which one is the one when order doesn't matter? I'll give you a hint. It was the one, like if we were choosing committees, then order doesn't matter. So which thing was the one where order does not matter? When you're choosing a small group of people, like you're choosing a group of people out of a larger group. A combination. Good, Natalie. Combination is when order does not matter. So for number 7, what's it called when order does matter? And on that one, that would be like if we were going to choose 3 people from the class, but they were going to be given titles like president, vice president, right, Kayla, permutation. So with a combination, order does not matter. But with a permutation, order does matter. Let's go on to number 8. Number 8 says, which of the following random variables is discrete? Can someone tell me what you're looking for if you're looking for which one is discrete? What is the difference? When is a random variable, or when is a variable a discrete variable? When you do what? What's the key word here? Discrete means you can what?
Count things.
Count them, right, Temperance? So we're looking at these things, and which one would be something you would count, as opposed to a continuous variable would be something that you would measure. Okay, and that could have in-between values. So discrete variables cannot have in-between values. So if you remember, I gave you a little like question you can ask is, can you have a half of it? Is there such thing as a half? If there's a such thing as a half, they're in between values, and that means it's continuous. So we're looking for something here that you would actually count. So of those,
The number of light bulbs.
right, that's correct. Good job. The number of light bulbs, you say, okay, there's 1, 2, 3. You can't have a half of a light bulb go out, all right? So you would count how many are out. You say, oh, I have 5.5 light bulbs out. No, you have 5 light bulbs out, or you have 6, but you can't have 5.5. So, but everything else could have halves. That makes them continuous with in-between variables. Let's go to number 9. 9 says, find the required value of the missing probability to complete the probability distribution. Now, to do this, 2 things have to happen in a probability distribution. We already said all the probabilities have to be between 0 and 1. And what was the other thing that has to happen? Someone remind me what the other thing is that has to happen on this? Equal 1. You mean that they add to 1, right? Temperance? Exactly. When you add them all, they should add up to 1. So I've given you 4 values, 4 probabilities there. So what you should do, You need to find out what they add up to and figure out what does that last one need to be so that they all add up to 1. So I'm going to leave that for you to figure out. Hopefully you all figure it out correctly. So everybody who's done it has gotten it right. Let's go on to number 10. Number 10 says, given the sample space, and we have, this is kind of like the one that we had on the last one, and this sample space is the numbers 1 through 12. 1, 2, 3. Sure will be nice when they quit working on our road and I can have some peace and quiet during class. I don't know if you guys can hear it, but this just drives me nuts. It's right out here outside my window. So this sample space, and they've given me 3 events. Now the question is to find the probability of E or G. And we did one just like this right before the break. So event E is made up of the numbers 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5 outcomes in E. And G is made up of 7, the numbers 7 through 12. Now I want you to notice something. That E and G are not mutually exclusive. The one we had last time, they were. That's going to make a difference on how you work this. Now, what I want you to do here first, I want you to practice what you would show me in your work, is I first want you to write out just the formula, no numbers. So starting with, this should be the probability of E. Then what should I put after that? So I'm only following my formula. What should my formula say? The probability of E, then what? What did you tell me or meant?
Plus the probability of G.
Right. And then we have to be careful. Try to think of an or as really being a plus and a minus, okay? Because there's something you have to subtract off, although sometimes it's 0, which it was the last time. But what is it in words? What are we having to subtract off here? If I apply the formula. And you're right, Mia, plus the probability of G. What needs to be subtracted off? Good job. E and G. The probability, right, the and. So now, what's the probability of E going to be? Well, first of all of your denominators are 12. Because that's how many numbers, that's how many outcomes, not numbers, but how many outcomes are in your sample space. What should be the top number for this one, for probability of E? This was the thing I did wrong before. Remember, I put, so 1, 2, 3, 4, yes, 5. Okay, what about for G? 6, good. What about E and G? Remember? Okay, Mia, good. So they had, notice they have 2 outcomes in common. So we're going to subtract 2 because we counted them twice. We want them once, but we don't want them to count twice. Okay, so now you've got a common denominator. All you need to do is add and subtract the numerators and reduce. So do that and finish that problem. We just have one more to go. And actually, on the multiple choice, it doesn't have it worked out, does it? It just shows the work. So I've already given you the answer. You see, it's just the work. Let's finish this one, though, because probably on the test you have to find the final answer. So this was the choice here, just the work. So, but that's 5 plus 6 is 11, minus 2 is 9. And then when we reduce that, dividing by 3, yes, you're correct, Mia, would be 3/4. Or if my stat lab wanted it in decimal form, we would divide 3 divided by 4, and it would be 0.75. Okay? And then I think just one more question. It's the same sample space, and it looks like it's the same. No, it's not the same event, so I need to change the events. The question is to find the probability of E prime, which means E complement, and so we need E up here. But the sample space is that. Remember, the sample space is the set of all possible outcomes. And event E is, on this one, 2 through 7. 2, 3, 4, 5, 6, 7. And it wants to know what's the probability of E prime, which means E complement. If I was just using the formula, no numbers, what should I put here? How do you find the probability of a complement, the complement of an event, or sort of like the opposite of an event? What should my work be here? That's what I would look for, is your work. And then the numbers. Anybody know what your work should look like? This is not on the formula sheet. This is a formula I expect you to know. Okay, temperance. I want you to write it first, though, without numbers, except the 1. The 1's okay. 1 minus what? I want you to write it with probability, kind of like we did here. It would be 1 minus, the probability of E complement, or E prime, is 1 minus what? I want you to write the formula first. And that may be the right number, but what is that 6/12? What does that represent? Y'all want to get the work right, right? Right. Well, I'll just leave that for you, okay? So, did temperance do it right? I don't know, because I don't know what this should be here. Just like we used probabilities here, what probability are we subtracting from 1 to get the probability of E prime?
None.
There you go. The probability of E, that's what I want to see. Right. So that gives me 1 minus, and the probability of E is going to be how many ways E can happen? 1, 2, 3, 4, 5, 6 ways E can happen. So temperance's work was correct. And then remember, we will rename 1 as 12/12. So we'll have the same denominator. And then that will give us 12 minus 6 will be 6 out of 12, and then that needs to be reduced. I'm going to leave that for you to reduce. And that's the last question in the Learning Catalytics quiz. If there's anything you didn't know from that, make sure that you write it. So you can see that there are going to be some questions on the test that are going to be pretty quick and pretty easy. That will allow you to spend more time on the others. But this is the sort of stuff you should just know so that you can do these very quickly. And that will leave you more time for doing the ones so you can just take your time, like make that chart for the variance of a discrete random variable. Take your time and show your work in the show work when I ask for it. Okay? So those are the things that you need to do and study for test 2, which I will make available on Wednesday. All right? So I will get it loaded and figured out. I haven't actually made it yet, but I'll make it and have it ready for you to take on Wednesday if you really want to. But I would recommend you not do that until you've got all your homework up to 90. And I would probably do that proctorio practice review that I put on there because it has some good review questions that are similar to what you can expect on the test. So I would do that too before taking the test. Remember, the test will be available until Sunday evening, but you should use Sunday as your backup day. And in your mind, think the test is due Saturday night. That way you'll know that you've got plenty of time. If you do it by then, if something goes wrong, hopefully we can figure out a way to fix it. And I have a proctorio number and contact information. That's also under tests. So be sure and look at that under tests. Kendra.